In the world of aerospace engineering, there is a ghost that haunts every new design. It is invisible, silent, and deadly. Pilots and engineers call it flutter. Imagine a massive jet, built of the strongest alloys, flying at 900 kilometers per hour. Suddenly, without warning, the wings begin to oscillate. At first, it's a tiny vibration, but in less than 2 seconds, it can grow into a violent flapping like a bird caught in a storm. If the frequency of the wind matches the natural frequency of the wing, the metal will snap like a dry twig. This is the ultimate resonance catastrophe. Before any aircraft from a small drone to a massive Boeing is certified to carry you, it must face this ghost. Pilots take the prototype to its absolute structural limit, reaching speeds over 1,150 kilometers per hour. Inside the cabin, there are no seats, only over 500 sensors and miles of orange data cables. The flight test engineer watches the screens intensely. They are looking for the damping ratio. They intentionally disturb the flight controls to trigger the vibration. You see the wingtip move up and down 12 times per second. It's a high-stakes dance where a 0.1% error in calculation could mean the aircraft disintegrates in midair. Why don't wings just stay rigid? Because in physics, rigidity is a death sentence. A wing that cannot bend will shatter under the first sign of turbulence. Engineers design wings to be barrel-ascetical. They are meant to flex, sometimes up to 5 or 7 meters at the tips. The secret is in the stiffness distribution. By carefully placing weights and composite materials, they ensure that the flutter speed is always far beyond what the aircraft will ever encounter in real-life service. When you see a wing flexing during a storm, you aren't seeing a weakness, you are seeing a calculated victory over physics. We learned these lessons the hard way. Early aviation history is filled with the unexplained mid-air breakups that we now know were caused by flutter. Today, with supercomputers and AI-driven simulations, we can predict the vibration point with incredible accuracy. But the physical test remains the gold standard. It's the moment where theory meets the brutal reality of the atmosphere. It's where we prove that the machine is stronger than the air it breathes. So, the next time you look out the window at 35,000 feet and notice a slight vibration, don't be afraid. You are witnessing the result of thousands of hours of flutter testing. The metal is singing its song of safety. Have you ever seen a wing flex so much it looked like it was going to break? Or do you prefer rock-solid flight? Let's discuss the physics of flight in the comments below.